day class. Today we are going to discuss about perfect square trinomials factoring. So we have here a trinomial composed of 3 terms, not 4 terms because 4 terms is different. So we have 1, 2, and 3 trinomial, and in all our examples here, we have 1, 2, 3, 1, 2, 3, they are all trinomial. Okay, to factor these perfect square trinomials, what are the requirements? Because it's a square, meaning if that is a square number, we can get its square root. So what are these square numbers? We have here our square numbers up to 100, but you can memorize up to 225 if you want. So this one is 1, because if we will take the square root of 1, it will give us 1, because 1 times 1 is 1. Square root of 4 is 2. 2 times 2 is 4. Square root of 9, 3. Square root of 16, 4. Square root of 25, 5, because 5 times 5 is 25. Square root of 36, 6. This one is 7 times 7. This one is 8 times 8. This one is 9 times 9. And this one is 10 times 10. And still have 121 for 11. 144 for 12. 169 for 13. 196 for 14. And 225 for 15. For the variables, we have x squared, x to the 4th, x to the 6, x to the 8, or we can say that if the exponent is an even number, then they are called square variables. Okay, let us look here and note of this trinomial. With this trinomial is really a perfect square trinomial. So how can we identify? We have two checking before we factor it and after we have factored it. But I recommend to you factor first and then you check whether the trinomial is a perfect square. Because if you are going to check here, that is usually used to check whether what number we're going to add to make it a trinomial. So here, how do we check? The conventional way of checking whether our trinomial is a perfect square, we get the numerical coefficient of the second term or the middle term. This is the first term plus this one is the third term or the last term. And the middle is here in between. Call this middle or second. We get its numerical coefficient, which is 8, and then we divide it by 2, always by 2, and then after dividing it by 2, we raise this one to the second power. Okay, so by PEMDAS, we have divide first, because this one is in bracket. We do first the bracket here, or divide first. We have 8 divided by 2 give us 4, and then we square it and it will give us 4 times 4 is 16. This one should be the last term and the last term is 16. Therefore, this is a perfect square trinomial. This one is a perfect variable. This one is a perfect variable. This is a perfect or a square number. A square number is 16. And that one is 16, so this one is a perfect square trinomial. Now this one, 10 divided by 2 is 5. 5 times 5 is 25. Oh yes. Okay, number 3, we have this one, x to the 4th y squared plus 2x squared y plus z squared. We check this one, 2 divided by 2 is 1. 1 times 1 is 1, then divisible 1 there. Now, this number 4 is a little bit different because just what I said before, it's better to check your trinomial after you have factored it already. It's easier than testing it before you factor it. Why? Let's have this one. Because we have the fourth one. Now, the numerical coefficient of the first term is not 1. This one is easy if we have the numerical coefficient of this one is equal to 1. But if it is not, then it's a little bit difficult to be confused, but it's still correct. Now 3 over 5, we divide it by 2, so it will become 3 over 10. Raised to the second power, the answer will be 9 over 100. And you'll be thinking, why is it as 9 over 100? It's 9 over 25. Why? Because of the 4 here. When you divide that 100 by 4, it still gives you the 25. So that's why I'm telling you that sometimes, I'm recommending you to use the second method, which I'm going to show you after this. Okay. So here, plus we take the half of 20. 20 divided by 2 is 10. 10 times 10 is 100. Okay, here. Okay, let us factor first this one. Okay, that is to check whether our trinomial is perfect square trinomial. Okay class, let's start with our example. So, we have to identify our trinomial, whether that one is a perfect square. So, first requirement is a perfect square trinomial has its sign on the last term or the third term is always positive. It should be always positive. It can't be a negative. So you will see in our example here that all the signs of the last term are all positive. This one is positive, 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 positive. If that is negative, it is not perfect square trinomial anymore. The first term is a perfect square, either a variable or a number. You can have a number here also. And the last term is also a perfect square. So if you have perfect square, then the sign is positive here. Maybe we are not yet sure whether that one is a perfect square trinomial. As we said before, that we can check that one if this 5 are perfect square trinomials by getting the middle term, dividing it by 2, and then squaring it. But this time we will do checking after we have factored that one already, because factoring is easier. And checking it when you have already the factors are easier. Okay. Now let's talk about the sign. So here we take the square root of this one, a squared, which is a. A times a is a squared. And then we take the square root of the last term. Square root of b squared is b, because b times b is b squared. What about the sign here? How do we find whether this one is positive or negative? You look at the sign of the middle term. Where's the middle term? Here. So what's the sign of the middle term? It is positive. If this one is positive, then this one is positive. If this one is negative here, the sign here will be negative also. Class, this one is a plus b to the second power. It's not really like that one. If you are going to write that one in a different form, we have a plus b times a plus b. There are 2a plus b, two binomials, and they are both positive or plus. If this one is minus a minus b, then we have a minus b times a minus b. We are not writing anymore this one. We are writing like this to the second power. But we can write this one like this also. Especially when we are dividing this one by another a plus b here, we can write like this instead of this one, and we cancel. What remains is this one. So let's start factoring this one. And we are assuming that they are perfect square trinomial. So here, We follow that one, and then square. And then, what's the sign of the middle term? Let us follow the sign of the middle term, or the second term. That is positive, so we put here the plus here, or this term here. We take the square root of the x squared, which is x, and we take the square root of 16, which is 4. It's a square number, 4. And then we take the square root of y squared. Don't forget this one. Usually the mistake of our learner is they will just put, or they will not put anymore the y squared or the y. So don't forget that the square root, or they will put the y squared there, which is wrong. So we have that one. Now we are going to check now this one if this is really a perfect square. How? Okay. We multiply, we have always the 2. 2 times the first term here times the second term. Don't bother with the sign. 4y. So when we multiply that one, this one is always there. The 2. 2 times x times 4y is equal to 2 times 4, 8xy. This should be the middle term of our trinomial, 8xy. Is this one 8xy? Yes. If this one is 8xy, then this one is a perfect square trinomial. And we can factor that one, and the factor is this one, x plus 4y times x plus 4y. Alright, next we have this one. So let's factor first. We don't care, they are perfect square trinomial. And we'll see that one after we have finished factoring. Sign first, okay? Sign. This is not always plus here. This one is always plus, but not here. This one is the sign of the middle term, which is negative here. This is the middle term, negative. So we put a negative here. Now let's take the square root of the first term. X squared, square root is x. And let's take the square root of the 25. Square root of 25 is 5. Because 5 times 5 is 25. It's still wrong. It is unfinished. What do we do? What is missing? The missing is the square. It is x minus 5 times x minus 5. Now let us check whether this one is perfect square trinomial. How do you check? We put again the 2 here. Don't forget the 2. Multiply always this 2 by the 2. So we multiply by the first term here and times the second term. So we multiply that one. 2 times 5, 10 times x. We have 10x here. Is this one 10x? Yes, it's a perfect square trinomial, and this is our factor, x minus 5 times x minus 5. Okay, number 3. Alright, put this one after the parenthesis. We write the sign. So where do we get the sign? It's the sign of the middle term. What's the sign of the middle term? It's positive. So we put the positive here. We take the square root of this variables. They are perfect square because they are even exponents, 4 and 2. Let's have the x to the 4th. Half of 4 is 2. So the square root of x to the 4th is x squared. Now what about the y squared? Y squared square root is y, because y times y is y squared. Now let's have the last term. Square root of 1 is 1. Square root of z squared is z. Okay. And then we put this square, signifying it's a square of binomial. Now let us check whether this one is a true or a perfect square trinomial. 2, don't forget the 2 here, and then copy the x squared, y, and then times the z, or the z. So we have here 2, so we have still 2 here, multiply that one, x squared, y, z. Is this one 2x squared, y? Oh, it's not. I forgot the z, okay class? And I'll put the z here to make it a perfect square trinomial. I forgot to put the z. So it's now a perfect square trinomial. But if you don't have the z here, this is not our factor. So we cannot factor that one anymore if we don't have the z here. So when you have the z, just I put it right. Now, if we have a z here, then it's a perfect square trinomial. And this is our factor for this one, square of binomial. But without the z again, no, we cannot factor that one anymore. We cannot have this one as our answer. So that's why it's better to check if we don't have and if we have. Okay, let's have number 4. For number 4, let's have this one. Okay, this is minus. So what we do, that is minus. Our sign is minus. So this one is a minus here. Now this one is fraction, so we put a fractional bar. We'll center our answer here, minus, and then here. Let's center anyone here. So x squared, square of x squared, x times x squared, 4, square root of 4 is 2. Not plus, because it's minus there. Or okay, square root of 9, 3, and square root of 25, it's 5, and then square. So it's easy. Now let us check. So when we check it, we write again the 2, because this one's fraction. I'm going to write over 1, so I know that the 2 is up. And then times. Alright, what is this one? That one is x above and 2 down. Just put everything here. And then here is 3 over 5. We multiply, then we can cancel this one and this one. So 3 times x is 3x and 5. Is this one 3x over 5? Yes. Therefore, this is perfect square trinomial also. So we have this factors for number 4. Okay, number 5. Okay, we have this square. We have the sign of the middle term, which is positive here. Now let's take the square root of x squared, x, square root of y to the 4th is squared. Because y squared times y squared is y to the 4th. And z, which is half of 6, which is cube. And then we have the plus sign here, and let's come here. Square root of 100 is 10, so we have 10 here. Don't forget the square. Now still perfect square trinomial, and our answer is this one. Our answer is correct. It's from our factory. Thank you, class, and